Alright, this is linear inequalities, and I want to start off with just showing you the notation. So here you have the notation. In the first column, it will show you how you write it. And then in the second column will be the interval notation. So we're going to need to write things in interval notation. The middle column is what most likely it's going to be graphed. And then the last one just tells you in words. And then something that I do want to add here is whenever you have a parenthesis, so that's a parenthesis, if you want to use an open circle, you can. And then for a bracket, if you want to use a closed circle, you can. So that's the only thing I will add for the graph. All right, moving on to some examples. We're going to go ahead and solve x minus 2 is less than 5, graph the solution set, and write in interval notation. So what we're going to do here is what we did with the linear equations. We're going to go ahead and isolate the variable. So in this case, I'm going to go ahead and add 2 to both sides. And so what I get is x is less than 7. So that's my answer because I already isolated the x on one of the inequalities. So now I'm going to go ahead and graph it. So we graph inequalities on number lines. And I'm just going to go ahead and maybe start with 4. And maybe go all the way to 9. So because this inequality doesn't have the equal sign, it's related to parentheses or an open circle, whichever one you wanted to use. So we're going to just go ahead and most people use the open circle. I put the open circle on top of the 7, and then it says x is less than 7. So all your numbers should be less than 7. So that would be over here. And then you could always check your answers. So, or in this case, it's actually test. So pick a value over here where you shaded. So let's say 4, and it should be true in the original inequality. So 4 minus 2 is less than 5. 4 minus 2 is 2. Yep, 2 is less than 5. So you shaded in the right area. And the last thing we have to do is write it in interval notation. So for interval notation, I like to think of this as infinity, actually negative infinity and positive infinity over here. So basically, your solution starts at negative infinity, and then it goes all the way to 7. And then remember, it has a parentheses because there's no underline. All right, let's move on to the next one. So the next one is 3x plus 4 is greater than or equal to 2x minus 6. So again, we're going to have to isolate the x. So what I'm going to do is I'm going to move the negative 4, or sorry, I'm going to subtract negative 4 on both sides. And then these cancel out, you bring down the 3x. And then you get 2x minus 10. I'm going to subtract 2x on both sides, and then you get 3x minus 2x, that's just x. And you get x is greater than or equal to negative 10. So you're going to go ahead and graph that. So I'm going to start at negative 12, negative 11, negative 10, negative 9, negative 8. And again, because now this is it has the underline as the equal sign. So now you're going to go ahead and use a closed circle. So a closed circle at 10, and this is saying x is greater than or equal to negative 10. So x is bigger than 10, so that's going to be on this side. And then again, you have positive infinity, negative infinity over here. So interval notation is going to be, it starts now, you always start on the left, so it starts at negative 10. And then you use the bracket because it has the underline, and then it ends at infinity. All right, moving on to our next one. We have negative and then parentheses x minus 3 plus 2 is less than or equal to 3 parentheses 2x minus 5 plus x. So there's quite a bit going on there. So we're going to go back to our 2.2 and we're going to try to simplify as much as we can on the left and the right. So I'm going to go ahead and distribute this negative. Okay, so that would be negative x plus 3 plus 2 is less than or equal to 6x minus 15 plus x. And then I'm going to see if I have any like terms on the left. So the 3 and the 2, I could combine that. Negative x plus 5. And then on the right, the 6x and the x, that becomes 7x minus 15. And then you could go ahead and do what we did on the previous one. So isolate the x. So I'm going to go ahead and add x to the other side. So it cancels out there. And then I'm going to try to do 2 steps in one. I'll do it with a different color. So I'm going to add 15, so the 15 cancels out. And you are left with 7x plus 7x plus x is 8x. And then you get 20 over here. So divide by 8. We get 20 divided by 8. All right, and that's going to be 2.5. And 2.5 is the same thing as saying 2 1/2 or 5 over 2. So depending on if somebody doesn't want you to write it in fractions, but you could do either one of the other ones. I'm gonna do just the decimal. So I'm gonna put 2.5, and then I'll put 2, 3. So I'm going by 0.5. And because this has an underline, we're going to put a closed circle. And then this is saying 2.5 is less than x. So 2.5 is the smallest number. So that means you're going to be shading over here. And remember, you could always check or test. So let's say we do 3. Yep, 2.5 is greater than or equal, 2.5 is less than or equal to 3. So we shaded in the right area. And now we're going to do our interval notation. So our interval notation, remember we start on the left, and this is infinity and negative infinity. So 2.5 to positive infinity. All right, and then our last one, it has fractions in it. So we're going to try to get rid of those fractions. So we're going to do the lowest common denominator. So lowest common denominator. So we have all the fractions that we have are 3 and 7. So we're going to go ahead and start and do a couple of multiples of 3. So we have 3, 6, 9, 12, 15. And then we're going to see, okay, do we need to do more? We'll just start with 7 now. All right, so we have 7, 14, 21, 28, and these are starting to get pretty big, so we're going to go back to 3. So the next one is 18, and then 21. So 21 is the first one that they both have in common. Now again, you don't always necessarily need to do this method, but it's just a method that's always going to work. And for example, you might already know that the lowest common denominator is 21, and you don't need to do that work. So let's go ahead and multiply every single thing by 21. So we're going to multiply this by 21, this by 21, and that by 21. So 21 times 1 minus 2x over 3 plus 21 times 3x plus 7 over 7, and then is greater than 21. So 21 divided by 3 is 7. 21 divided by 7 is 3. We're going to go ahead and distribute that, 3 and 7. So we're going to get 7 minus 14x plus 9x plus 21 is greater than 21. All right, and then remember we're trying to isolate the x, so I'm going to go ahead and move all the numbers, 21 and 7. These will cancel out. And then 21 minus 21, that's just cancels out. So all we're left with is negative 7. And then we're going to go ahead and add negative 14 plus 9. That gives you negative 5x. All right, so we have to divide by negative 5. Now, remember, when you divide by a negative, you have to flip the sign. So we're going to go ahead and get x is less than 7 over 5, and then we're going to go ahead and graph that. So 7 over 5 is in between 1 and 2. I'm going to try to have at least 5 digits there. And then because this doesn't have the underline, it's an open circle. And then it says x is less than. So I'm just going to scroll all the way up just to show you that you could use this chart. This is what we're looking at, right? X is less than that number. And so we know it's going to be going to the left. Okay, and then interval notation, again, if you go back to that chart, it'll show you how to write that interval notation. Negative infinity to 7 over 5 with parentheses. And that's it.